another example on integration by parts. So let us start working on this particular example. Guys, here we have again product of two functions. Here I have an algebraic function which is a quadratic function because of an x square, and then there is this log function. So guys, the first thing we have to do is we have to look at this this short form, or this way of like deciding which function we have to set as an f and which function we want to set as a g, the first and the second. So obviously you can see that the log function has to be preferred first before the algebraic function for choosing the f function, right? So we start with log as f and algebraic as the second g function. So guys, the first step that I would like to do is I would like to rearrange this. So this I can rewrite it as ln of x, because it's multiplied, so it does not really matter whether I write it as a times b or b times a, so or f times g or g times f. So guys, here this is the first step. From here now I know that the first function I have to treat the log function as my f and this as my g. Now once I do that, then what do we do next? Next we just go back and look at the integration by parts formula and try to apply the formula. It says first just take the f, which is ln of x, and then times integral of g. So I'm just going to write that first step, integral of g dx, and then minus integral of f prime. Guys, I don't have to write f prime here. We already know that the integral of the derivative of f, which is f prime. So derivative of f function, which means the derivative of the log function, is just the inverse function 1 over x. So I can write 1 over x for f prime, times then I have integral of the g function, which is the same thing, x squared minus x in parentheses. It's a binomial dx. Of course there's another dx all the way at the end. Okay guys, that is step number I would like to call it step number 1, because this was just like we had to rearrange to make sure that we have the right f and right g. Let's move on and see how we can simplify. Ln of x is all, we cannot do anything with it. We don't have to do anything with it. Then let us try to do the integral for this function. It's a simple algebraic function, so you just have to use the power rule, x to the power n, and we can like put it in parentheses. It's a binomial. There will be two terms for the integration as well. So the integral of x squared is simply x cubed over 3, right? Raise the exponent, add 1 to the exponent and divide by the same thing, so x cubed over 3. And then what would be the integral of this? There's an invisible 1 here, so it would be x squared over 2. That takes care of the first integral, and then minus, and let us see what we can do with this one. Guys, I don't have to do anything with this 1 over x yet. All we have to do first is we have to first simplify this inner thing, the integral of this quadratic function. So we already have the integral of that quadratic function, so let us put it back here. So it's x cubed over 3 minus x squared over 2, and then we have a dx, right? That is step number 2 here. We are simplifying, and then, well, this is already simplified. So usually we like to write the algebraic function first and then the log functions. Guys, it does not really matter as long as it's multiplied, but I mean usually the textbooks prefer to have this first and then the log function. So we already took care of this piece. Now let us see what we can do on this side. So guys, in this side, again, we cannot directly start integrating this. So what we should do first is we should first try to simplify this piece inside what we have to integrate. So that means we should try to distribute first so that we can simplify, and then we should try to take or do the integral. Okay, so when I distribute 1 over x with this, so there's an x cubed here divided by x, so I'll be left with x squared over 3. That would be my first term. And then when I distribute that 1 over x with the x squared over 2 term, the x and x squared will cross out. I will be left with just, of course, there's a minus x over, and then there's a 2 here, and that's it. Okay. So we are up here. Guys, now we need more room to, I mean, this is already simplified. We just have to simplify this. And just by looking at this, it just looks like we just have to use the power rule for integrals, right? So it should not be too difficult, but let us make some room and then we'll simplify this. So what I'm going to do is, again, I'm going to get rid of this here. Probably I need this room as well. Let's see if I can squeeze everything in this. So this is going to look like this. We just have to rewrite. So it's x cubed over 3 minus x squared over 2 times the ln of x. Okay, we don't have to do anything with it. And now here, guys, there's a minus here, and then I'm going to put I like to draw these square brackets. You can put it regular parentheses, that's totally fine. Guys, these are two pieces, so we have to kind of break them down, integral of this piece as well as the integral of the second piece. So let us do piece by piece. Guys, the integral of this guy, this whole thing would be x to the power 3 over 3, but there's already a 3 here, so I just have to keep that 3 as well. So this 3, one of the 3's is based on n plus 1 using the power rule, and the other 3 is already there, so I just rewrote it. That takes care of the first one. Then we also have to do the integral for the second piece. Keep in mind there's an invisible 1 here, so and then there's a minus here. So integral of this guy is simply x squared over 2, but there's a 2 downstairs as well, so I have to put that 2 as well downstairs, and then that's it, plus a c. So I think we're almost done. Let us go ahead and simplify this and write the final answer. So it's x cubed over 3 minus x squared over 2 in parentheses ln of x, and then guys, let us simplify this. Simplifying here means we just have to distribute that negative and get rid of those square brackets. So it's going to be minus x cubed over 9, 3 times 3 is 9, and then what do I have next? I have negative times negative, which is positive, and x squared, 2 times 2 is 4, plus a c. So finally we had enough room to kind of get this final answer. Okay, so guys, this is the integral for this. I mean, in this case, we did not have to actually repeat, like we did not have to do this integration by parts twice. We just did it once. And then by choosing the right f and right g based on this technique, we were able to simplify things. And finally, we just had to, like, at the end, we just had to integrate an algebraic expression. We could do that using the power rule, and we were able to get the final integral. Guys, example 3 is done. This involved logs. In my previous examples, I have done the trig functions and I did the exponential function. So I want to show you like all different types. In my next example, I want to show you something slightly different. So guys, till then, take care. I will see you next time.